Welcome to Lesson 1.3, Writing Expressions. We will first learn how to translate verbal phrases into expressions. If you're given a verbal phrase, 4 less than the quantity 6 times a number n, the expression would say 6n minus 4. If you're given a verbal phrase that says 3 times the sum of 7 and a number y, the expression would be translated to say 3 times the quantity 7 plus y. If the verbal phrase says the difference of 22 and the square of a number m, the expression would say m squared, 22 minus m squared. Guided practice. 1. Translate the phrase, the quotient when the quantity 10 plus a number x is divided by 2 into an expression. So then the expression would say 10 plus x divided by 2. Let's look at a word problem. Cutting a ribbon. A piece of ribbon L feet long is cut from a ribbon 8 feet long. Write an expression for the length in feet of the remaining piece. Solution. First, you need to draw a diagram and use a specific case to help you write the expression. Suppose the piece cut is 2 feet long. Suppose the piece cut is L feet long. So here is our image. Our original image is 8 feet long. So if we cut 2 feet off, then the remaining piece is 8 minus 2. So if we substitute that with L, cutting L feet long off, then our remaining piece would be 8 minus L. Therefore, the expression 8 minus L represents the length in feet of the remaining piece. Here is a tip. Oh, this is about tips. You work with 5 other people at an ice cream stand. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share in dollars of the tips. Step 1. You want to write a verbal model. So the amount in the jar will be divided by the number of people. So secondly, you want to translate the verbal model into an algebraic expression. Let A represent the amount in dollars in the jar. So then we have A divided by 6. An expression that represents each person's share in dollars would then be A divided by 6. What if? In example 2, suppose that you cut the original ribbon into P pieces of equal length. Write an expression that represents the length in feet of each piece. Since the original piece of ribbon was L feet long, and we want to divide it into P pieces, then our answer is L divided by P. In example 3, suppose that each of the 6 workers contributes an equal amount for an after-work celebration. Write an expression that represents the total amount in dollars contributed. (6D), where D represents the amount contributed by each worker. Example 4. A car travels 120 miles in 2 hours. Find the unit rate in feet per second. So we need to convert to seconds, to feet per second. So what you want to do is you take the given original amount. So 120 miles per 2 hours is our original fraction. We want to first convert the miles to feet. There are 5,280 feet in a mile, and then multiply that by our conversion from hours to minutes. So there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So notice that the units will cancel out, and then you're going to multiply across the numerator, and then multiply across the denominator, and then you will reduce. So your answer is 88 feet per second. Example 5. Solving a multi-step problem. For a training program, each day you run a given distance and then walk to cool down. One day you run 2 miles and then walk for 20 minutes at a rate of 0.1 mile per 100 seconds. What total distance do you cover? Step 1. You need to convert your walking rate to miles per minute. So since we will take our original fraction, 0.1 mile over 100 seconds, multiply that by 60 seconds per minute. This will give us 6 miles per 100 minutes, which is 0.06 miles per minute. The second step is to write a verbal model and then an expression. Let m be the number of minutes you walk. So we're going to add the distance that you run plus the walking rate times the time spent walking in minutes. Use unit analysis to check the expression. So you have 2 plus 0.06 m, which is reasonable. Okay. Miles plus miles per minute times minutes will give you miles plus miles, which gives you miles. So our conversion is correct. Because the units are miles, the expression is reasonable. The third step is to evaluate the expression when m equals 20. So plug in 20 for m, and your answer is 3.2. So you covered a total distance of 3.2 miles. Guided practice for examples 4 and 5. In example 1, suppose tomorrow you run 3 miles and then walk for 15 minutes at a rate of 0.1 mile per 90 seconds. What total distance will you cover? So you want to do your conversion from minutes and seconds, and then your answer will be 4 miles. This concludes our lesson.